Hello everyone, welcome back to Infinity Physics. In the last lecture, we had a discussion about momentum. In this lecture, we will discuss about Newton's second law of motion. Now, before that, I have asked some questions in the last lecture and the correct answers are given by Bharvi Dudashia. So, congratulations Bharvi, and I hope in this lecture you will also give the correct answers of the questions that I will ask. And another request to all the students, whenever you are watching my video, so confirm your attendance by pressing the like, and also if I ask any question at the end of the lecture, please give the answers in the comment section, so I get to know that how many students are watching my videos. Now, to understand the Newton's second law of motion, there is a one scenario that you have to understand. Here, an object of mass m is initially at rest. Let us assume that initially at rest. Now, you are not applying any force. Then what will happen? The ball will not move. Means its initial momentum is zero. Mass into velocity. Right? So, initial momentum is zero. Now, suppose you are applying some force on it, then what will happen? It may possible that here mass m and here you give some force, then what will happen? Its velocity changes to v and its momentum becomes m into v. So, let us assume that the momentum of a body, initial momentum is 0 and the final momentum changes to, let us assume that 100 kg meter per second. Now, the same ball is there, okay, and you are applying the larger force. Let us assume that to attain this momentum, the ball take 2 seconds. Now, in this case, you are applying larger force. Then what will happen? To attain the same momentum, it will take the smaller time. So, whatever change you are providing, okay, that change is attained by the object due to the force. Means here force is responsible for change in the momentum. Means if you are not applying any force, then there will be no change in the momentum. Again, let's try to understand the same scenario in a different way. Suppose there is an object having mass 5 kg and it is moving with velocity, initial velocity 5 meter per second. Then what is its momentum? Its initial momentum is 5 into 5, that is mass into velocity. It is 25 kg meter per second. Now if you won't apply any force, then what will happen? The ball will move with the same momentum, 25 kg meter per second. Now suppose you are applying a very small force for a large interval of time, means for 10 seconds, 20 seconds, right? Then what will happen? You are applying a very small force. Then the ball will take some time to change its momentum from 25 kg meter per second to, let us assume that the velocity attained by the ball is 20. Then in this case, what is the momentum? The final momentum is 100, right? So by applying the unbalanced external force, we have changed the momentum of a ball from 25 kg meter per second to 100 kg meter per second in 10 seconds. Let us assume that, right? In 10 seconds, because we have applied very small force. If we won't apply any force, then there will be no change in the momentum. So we can say that whatever the change in the momentum, that change in the momentum is provided by the external force. Means the change in the momentum is proportional to the external force. Again, the same ball, but we are applying a very larger force. For example, a football is there, right? You can kick the football very slowly, right? Then slowly its speed will increase. Or you can kick it with a very large force. Then in a fraction of second, its speed will be very large. So same thing applied here. So here again, let us assume the same ball which is moving with the 5, having the mass 5. and moving with the 5 meter per second. So initial momentum is 25 kg meter per second. Now you are applying a very large force in a very short interval, right? So in the first case it takes the time 10 seconds to reach the velocity of 20 meter per second, or we can say that to attain the momentum of 100 kg meter per second. But here you are applying a large force in a very short time. Then what will happen? The ball will attain the same momentum in a very short interval of time. That is, from 25 its momentum will change to 100 in just let us assume that 4 seconds, right? Because in this time you are applying larger force in a very short time, right? So whatever the change in the momentum is depend on two things. One, how much force you are applying, and another thing, for how much time interval, for what time interval you are applying the force, right? So you have understood this thing, right? Okay, whatever the change in the momentum is totally depend upon the applied external force. If you don't apply any force, then there will be no change in the momentum. Okay, so let us try to understand this statement. It states that the rate of change of momentum of a body is directly proportional. See here again, the rate of change of momentum means the change in the momentum of a body with respect to time. This rate indicates we are comparing with the time. So whatever the change in the momentum of a body with the time, that's why I have given the example with the time. So whatever, so here change in the momentum, that is initial momentum was, let us assume that P1 and final momentum is P2. So the change in momentum is P2 minus P1 by, we have to compute the time, right? So is proportional to the applied external force, right? So this statement indicates that the rate of change of momentum means this: the change in the momentum by time is directly proportional to the applied external force. And we have seen the example, right? Okay, here there is an object, it's moving with initial velocity u, it has initial momentum mu. Now if you apply some external force, then due to that force the momentum will change. Means whatever the change in the momentum will takes place is directly proportional to the force. So when an unbalanced force is applied on an object, it changes its velocity, which is in turn changes its momentum. So it is concluded that the force necessary to change that momentum of an object depends upon the time rate at which the momentum is changed. So if you have applied larger force, then the change in the momentum is very faster, right? So why very faster? We have compared here with the time. So here again we need to consider the time. So that is the rate of change of momentum. Similarly, if you apply smaller force, then the rate of change of momentum will be very smaller. So whatever the rate of change of momentum means the change in momentum per unit time, and it is totally depend upon the applied external force. Now let us try to derive a very famous equation. Okay, and to derive that we have to assume something. So let us start. Let mass of an object be m, means an object is moving with some velocity u and its mass is m. Let its initial velocity is u and final velocity is v. We know that the momentum p is equals to mass into velocity. Therefore initial momentum mu, final momentum mv, and if you apply force, then the momentum will change from mu to mv. So how much change we have found? That is mv minus mu, that is final momentum minus initial momentum. So in that case, in the first case I have given you example, the final momentum was 100 and initial momentum was 25. So what change we have obtained? It is 25 kg meter per second. Now from the statement of the second law, we have seen that the rate of change of momentum is equals to, okay, the rate of change of momentum means change in momentum per unit time. Remember this, rate of change of momentum means change in momentum per unit time. So here there is a mistake, it is mv minus mu. Actually it is here mv minus mu. Okay, so in the last slide, what we have seen here, change in momentum is mv minus mu. So what is rate of change of momentum? So we have to divide it by the time. So that is mv minus mu by time. So this indicates rate of change of momentum, that is change in momentum with respect to the time. Rate of change of momentum means change in momentum with respect to time. Then now from the Newton's second law of motion, we have force is proportional to rate of change of momentum. So this statement, if you see the statement of the Newton's second law, the rate of change of momentum, that is mv minus mu by t, is proportional to the applied external force. The meaning of the statement is this. So we can put mv minus mu, here mu is there, right? So mv minus mu by t is proportional to applied external force. Now the object's mass remains same when it is moving, right? So we take m as a common. So if in this equation, if you take m common, then what we will get here? M common, then v minus u by t. Now v minus u by t means it is a rate of change of velocity or change in velocity per unit time, and that is called the acceleration. Right? So here we can write f instead of v minus u by t, here we can write acceleration a. So here m as it is. So f is proportional to ma. Now to remove the proportionality sign, we need to multiply it with some proportionality constant. And when we multiply, we will get exactly equal to sign. So here to remove the proportionality sign, we have multiplied with some constant, and that constant is called the proportionality constant. So f is equals to kma. But scientifically, with some experiment, it was found that the value of the constant k is 1. So again, if you put the value of k is equals to 1, then we will get f is equals to ma, where f is equals to force, m is equals to mass, and a is equals to acceleration. So we can say that the force is equals to mass times acceleration. See, the first law gives the definition of the force, while the second law gives the magnitude of the force. Right? So remember this thing. The second law gives the magnitude. That is how much force is acting can be calculated with the help of the second law of motion. So I hope you have understood the derivation. Now, there are some numericals which will make your understanding very clear. So first one, how much net force is required to accelerate a 1000 kg car at 4 meter per second square? That is, a car is there and I want to accelerate with the acceleration of 4 meter per second square, means I want to change its velocity from 0 to 4, 4 to 8, 8 to 12. So here every time the change in the velocity is 4, 4, 4, 4. It means the acceleration is 4 meter per second square. So how much force I need? So simple, F is equals to ma. So m is 1000 kg and what is the acceleration is 4. So I need 4000. What is the unit of force? It is Newton. So 4000 Newton force. Similarly, a car starts from rest, right? Means if it starts from rest, then initial velocity is u is equals to 0, and acquires a velocity of 54 km per hour in 2 seconds. 54 km per hour. See, whenever you find the speed in kilometer per hour and there is a use of acceleration in the question, then every time you convert that velocity or speed from kilometer per hour to meter per second. Now to convert, there is a shortcut trick. See, v is equals to what is given? 54 km per hour. So 54 into 5 by 18. You just multiply it with 5 by 18 meter per second. Okay, so here 18, how much it will take? 18 3s are 54. So 3 5s are 15. So it's increased its speed from 0 to 15 meter per second. because 15 meter per second is the 54 kilometer per hour in the kilometer per hour unit. So remember these things. Then we move ahead. So initial velocity u is equals to 0, u was 0, final velocity is 15 meter per second, and time taken to increase its velocity from 0 to 15 is 2 seconds, which is given. So what is the acceleration? A is equals to v minus u by t. So it is asked to find the acceleration. So final velocity is 15, initial velocity is 0, and time is 2. So 15 by 2 means 7.5 meter per second square. Now here it is asked to find the force. So you have acceleration and you have mass. So in the comment section you can give the answer of the second one by using the formula F is equals to ma. Mass is given and acceleration also we have find. Question number 3. A body of mass 10 kg undergoes a change of velocity of 10 meter per second in 4 seconds. What is the force acting on it? See here, there is a tricky question. The change of velocity 10 meter per second means its velocity changes from 0 to 10 or 10 to 20, means change in velocity is 10 meter per second in 4 seconds. So change in velocity means A is equals to change in velocity v minus u by t, which is given 10, and time taken is 4 seconds. Then what is the acceleration? It is 2.5 meter per second square. Right, meter per second square is the acceleration. Now what is asked? We have to find the force acting. So we know that F is equals to ma. What is the mass given? Mass is given 10 kg in the third question, see, and acceleration we have obtained, it is 2.5. So the force acting is 25 Newton. Again, question number 4. A car of mass 1500 kg moving at the speed of 108 km per hour and suddenly applies brake and decrease its speed to 36 km per hour in 2 seconds. Find the force applied by the brake. So again here the data is given in kilometer per hour. So first you convert the 108 km per hour into meter per second and 36 km per hour into meter per second. So our initial speed is this, and when we are applying brake the speed decreases. So here v is equals to this, you convert this into meter per second, right, and then again our final speed is v 36 km per hour, convert it into meter per second. Then you can use the formula, that is a is equals to v minus u by t. Then here time is also given, so you will get the acceleration. Then what is asked? What is the force applied by the brake? So you can use F is equals to ma. Mass is given 1500 kg. Okay, so I know you can do this. So give your answers in the comment section. Here the force and the acceleration both will be negative. Okay, so don't worry about that. Question number 5. A force of 500 Newton acts on a body for 2 seconds. Find the change in momentum. So here we know that F is equals to ma, or we can write mv minus mu by t. We can write this, right, because acceleration is v minus u by t. And what is asked? What is the change in the momentum? So mv minus mu, I can take t this side, so it is force into time is equals to mv minus mu, right. Mv minus mu means it is a change in the momentum, right, and so change in the momentum is equals to force into time. So now to find the change in the momentum, I can write force into time. So delta p, delta means here change in momentum, triangle means delta, so delta p equals to change in momentum, and that we have obtained force into time. So what is force given? 500 Newton. What is time given? Second. So the change in the momentum is, we can say it is 1000 Newton seconds or 1000 kg meter per second. Newton second is the another unit of the momentum. So don't worry about that. I hope you have enjoyed my lecture, and next lecture I will upload of the Newton's third law of motion, and also we will discuss some amazing phenomena that are related to the third law of motion. So have a nice day. Thanks for your support and trust.